The MSI GE65 offers some pretty powerful specs for a gaming laptop, but just how hot does it run, and is there any lost performance from throttling? In this detailed thermal testing, you'll see how hot it runs and find out what simple changes can be made to improve performance. I've got the 9SE version of the GE65, so there's an Intel i7-9750H CPU, NVIDIA RTX 2060 graphics, 32GB of memory and dual channel, and a 144Hz 1080p screen. It's also available with different specs, including RTX 2070 or 240Hz screen. You can find examples of other configurations and updated prices linked in the description. Air is pulled in underneath the machine through the large mesh area towards the back. It's then exhausted from the left and right corners out the back and back left corner. There's no exhaust on the right side, so your mouse hand won't suffer. There are a couple of heat pipes shared between the processor and graphics, with 7 heat pipes in total. The MSI Dragon Center software is the control panel for the machine. It allows us to swap between 4 different performance modes, which from lowest to highest are Eco, Comfort, Sport, and Turbo. Turbo mode is the only one that overclocks the GPU. We can also adjust the fan speed. I've tested with the default auto profile and cooler boost mode, which basically sets the fan to maximum speed. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. At idle, both the CPU and GPU were looking okay. The rest of the results are from combined CPU and GPU workloads, and are meant to represent worst case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the AIDA64 CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. In Eco mode, the temperatures are looking good, but as we'll see later, this is because the power limits are capped hard so there's minimal performance. When under stress test, the CPU was thermal throttling at 95 degrees Celsius under this worst case workload. However, it was possible to avoid this by setting the fan to max speed with cooler boost mode. Similar was seen while gaming in that regard, though I wasn't quite seeing CPU thermal throttling as much with the fan on auto speed. However, maxing out the fan clearly made a nice improvement. Applying a minus 0.15 volt undervolt to the CPU helped a bit more, but using a cooling pad made the largest improvement, which makes sense when you consider how much space is underneath for extra air to get in. These are the average clock speeds for the same tests just shown. Again, Eco mode was way down as this mode caps power limits significantly to keep it running cooler and quieter. Whether gaming or under worst case stress test, there was minimal CPU clock speed change between Comfort, Sport, and Turbo modes, as the limitation was thermals. Turbo mode did see higher GPU speeds though, as this overclocks the graphics. Swapping from auto fans to cooler boost mode improved things a little. However, the largest boost was achieved by undervolting the CPU. Adding in the cooling pad took us to the full 4.0 GHz all-core turbo boost speed of the i7-9750H when under stress test. So with some tweaks, even under this worst case example, it was possible to get full speed. These are the average TDP values reported by Hardware Info during these same tests. In Eco mode, we can see why the performance was so low. The CPU was only allowed to run at 7 watts. In all other modes, the RTX 2060 was able to run at its maximum 90 watts, so no problems there. While under stress test, with the fan set to auto mode, the CPU is below the 45 watt PL1 due to thermal throttling. However, as this was removed with max fan speed, we can see the next limitation preventing higher clock speeds was the power limit, which is why undervolting helped out here. In the gaming tests, the 45 watt limit for the CPU was reached in comfort mode and above, as thermals were less of a constraint in this particular game, to the point where undervolting was enough to prevent power limit throttling entirely in this particular test. I'll also note that I wasn't able to boost CPU TDP through Intel XTU when under combined CPU and GPU stress test, so 65 for the CPU seems to be the limit. Granted, this seems fine given the stock temperatures noted earlier. Here are the CPU clock speeds while under a CPU-only stress test. The results are higher as the GPU is idle. Sport mode and above were able to hit the full 4 GHz turbo boost speed in this test. If we look at the temperatures, we can see they peak at 85 degrees. However, undervolting the CPU lowered the temperature massively. This is because less power equals less heat, and by undervolting, we're using less power to get the same amount of work done. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks from these same modes. Like we saw in the clock speed results previously, there's a nice jump in performance with the undervolt applied, though there was pretty much no difference between sport and turbo modes. With the undervolt, the results are pretty good. 3000 points is a decent score for a well-performing 9750H. To see how these different settings actually affect gaming performance, I've tested Shadow of the Tomb Raider with the highest setting preset using the game's benchmark tool. There's really minimal difference outside of eco mode, and we can see that the CPU undervolt was able to give a little boost. If you want to see more gaming benchmarks on this machine, check the card in the top right where I've tested 21 games at all setting levels. As for the external temperatures where you'll actually be putting your hands, at idle it was in the low to mid 30s, pretty standard. With the combined CPU and GPU stress test running in turbo mode with the fan on auto speed, it's barely getting to the mid 40s in the center. Then with the same test with cooler boost enabled, we can see it's a bit cooler due to the higher fan speed. It was a little warmer after playing an actual game for an hour, but it was hardly even warm to the touch. Here's what the fans sound like during these different tests. At idle, the fan was only just barely audible. With the stress tests going in eco mode, it's still on the quieter side. Comfort, sport, and turbo modes were all around the same with the fan set to auto speed, which was about 10 decibels higher than eco mode. However, compared to most other gaming laptops I've tested, at this point we're still below the average. Then cooler boost is a little louder. In terms of gaming, eco mode wasn't really playable as it caps performance so hard, so don't rely on it for quieter gaming. Overall, the GE65 was running on the hotter side at stock, at least when under worst case combined CPU and GPU stress test. While playing an actual game, it was a bit better. However, as we've seen, simply raising the fan speed with cooler boost mode was enough to remove thermal throttling in my tests. The next roadblock was the 45W PL1 on the CPU. However, by undervolting the CPU, it was possible to hit the full 4GHz all-core turbo boost speed of the 9750H, both in games and under stress test. So we can get some extra performance with simple changes. The cooling pad didn't really affect performance much, but it did help further lower temperatures by a fair amount. It's good that MSI are giving us so many different modes to run the laptop. There's quite a bit of user choice, which is always a good thing in my opinion. It's worth keeping in mind that the GE65 is also available with the higher tier RTX 2070, which has a higher power limit, so I'd expect higher temperatures with that configuration. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results. Primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements, so don't just blindly copy my settings and do some testing to find out where your stable point is for best results. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. Raising fan speed, undervolting, and using a cooling pad are much easier for most people to do than changing paste anyway. And as we've seen, these tweaks did help improve performance and temperatures with the GE65. Let me know what you thought about the thermals from the MSI GE65 gaming laptop down in the comments. And if you're new to the channel, you'll definitely want to get subscribed for the upcoming full review to see everything this machine has to offer.